There's really no way around this. You're going to have to memorize quadratic formula, okay? So very rarely on the SAT is quadratic formula important, and I would hope that even though this quadratic looks kind of crazy, that there's going to be some shortcut that would help me. And ignoring the answer choices for a second, I do see one thing that I should do, which is I should divide everything by 3, right, on both sides. Because that makes these numbers smaller, right? Then it becomes x squared plus 4x plus 2. And then ideally, I would be able to factor that. But there's no numbers that multiply to 2 and add to 4, at least no convenient numbers. So we've got a problem here. We're not going to be able to factor this in the normal way. But that first move where I divide by 3, that's really important because a lot of times on the SAT, it looks like we have a very complicated quadratic, but a simple move like that, factoring out the greatest common factor, or dividing by it, that makes it go from crazy looking and hard to actually pretty standard. So you should always do that move if you can. But looking at the answer choices here, we kind of knew from the start this wasn't going to be nice, right? All the answer choices tell us we're going to need quadratic formula, so we do need to have that memorized. So hopefully you do. It's something that's kind of important. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, okay. What does that mean? Well, most quadratics are going to follow the format ax squared plus bx plus c. And so all of these letters correspond to numbers that would appear in the equation. So our job is to make sure we have the right number. So for the sake of clarity, we can see here that a is 1, right? Because it's not written there, but it's implied that that's the first number before that x squared. B is 4, and c is 2. Now if I hadn't divided, I would have had bigger numbers. I would have had a is 3, b is 12, c is 6, and those numbers would have gotten me actually the same answer, but it would have added in more steps, bigger math to do in the equation, which is already confusing. So smaller numbers are better. So let's just plug in here. Negative b is negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 2 all over 2 times 1. And notice that a lot of the arithmetic that we're now going to have to do is really simple, but I didn't do any of it while I was writing this stuff down. I can do some math in my head, but we're going to be a couple hours deep in this SAT at this point. I don't trust my brain to keep track of every number. So show your work on the page. Don't skip steps. So okay, first things first, negative 4 is just negative 4. 4 squared is 16. 4 times 1 times 2 is 8. And on the bottom we have 2. Now the mistake most people make is while they combine these two numbers, so x equals negative 4 plus or minus the square root of 8, they also divide these two numbers, 2 and 4. Can't do that. The reason is that this plus or minus, it forces us to treat the top of this equation as a unit, right? So the plus and minus don't mix with division very well. Addition and subtraction go together very well. Multiplication and division go together very well. But we can't, those are two separate worlds, and it's hard for us in algebra to mix addition, subtraction with multiplication, division. They don't mix well. And in order to mix them, we usually have to do some form of distribution. And we are going to need to do that here. But first, what we want to do is clean up the radical. Radical 8 needs to be simplified. So let's do a little sidebar here. How do we break up a radical? How do we simplify it? Well, I like to think in terms of factors. So I take my 8 and I split it up into a 4 and a 2. But I go all the way. I break every number I have down into its prime factors. So 8 is really 3 2's. And because it's a square root, what I want to do is I want to find pairs of the same number. So for 8, that's really easy, right? So I can say, oh, okay, there's a 2, there's a pair of 2's, but there's also a 2 left over, right? A 2 that doesn't have a mate, it's all alone. So what happens is when I simplify the radical, the pair of the numbers comes out of the radical, so that's this, and then the leftover stays behind, so that's this. And so that would be easier for me to show you if I had different numbers in the pair and alone, but 8 is just a bunch of 2s, so I can't really do that. But that's the general rule, is you're looking to make a pair if it's a square root. If it's a cube root, you're trying to make a triple, but you're always looking at the factors, the most basic prime factors of a number. You're trying to break it apart as much as you can so you can group things and see what comes out and what stays behind. So now I have that x is equal to -4 plus or minus 2 root 2 over 2. And now I can deal with the division, because this 2 can be distributed to both of the pieces of the top, right? It's almost like the top piece is in parentheses. And if we had parentheses and we were trying to multiply, we would have to multiply by both parts because distribution. Well, division is kind of like multiplication, and so the same thing applies. If we have a grouping of numbers with parentheses, we distribute division to all the pieces. And so it looks a little weird, but it's a normal rule of math, okay? So what ends up happening? Well, -4 divided by 2 is -2, plus or minus 2 divided by 2 is 1. So these 2's are going to go away and leave us with just a square root of 2. So we never really get into the radical with these numbers. Everything that once we have the radical simplified, we never really go back into it. And the short version of why is that it's kind of like these are in parentheses too, and we can't really break into those parentheses very easily. So it's radicals are kind of their own thing. So we got addition and subtraction, we got multiplication and division, and then we kind of got exponents and radicals also on their own. It's a giant mess, math. But these different worlds don't mix very nicely. And so for that reason, we're done. That is the most simple version of what we have. And is that an answer? -2 plus or minus root 2. That's choice A, and that is the correct answer. It's a lot of work. And honestly, this is not a high priority question. Number one, quadratic formula does not come up very often on the SAT. Occasionally it does, and when it does, you're pretty much screwed unless you have it memorized. So if you're looking for an 800, you have to memorize it. But if you're not looking for an 800, first of all, it's a low priority to memorize. But it's also a low priority to do and to solve. Look at how much time that took us. And here's the thing, is if we made the most common mistakes, we would have gotten an answer. So we would have done a lot of work and wasted a lot of time only to get the wrong answer, even though we would have been very confident in that answer because it would have been there. And so the most common mistake people make is the one, I did right here with the division, or almost did, and that would have caused some issues. So just keep that in mind. If you are someone who runs out of time on the no calculator section, this is not a question you should be wasting your time with. You should pick your favorite answer and move on. Just pick a letter and go on, because question 15 might be easier, but also question 16 certainly will be easier. Remember, the first few grid-in questions are reset the difficulty. So those are supposed to be pretty easy, and so there's like 20 or 30 points just sitting there in questions 16, 17, and 18, and I'd hate for you to miss those points just because you spent so much time on something like this. So just keep that in mind. It's a choice you have to make sometimes when you're running out of time on a timed test.